Who's that boy? Who's that boy? It's Evan. I'm the new boy. Today is one of my favorite topics. It is also our last lecture topic of the year. So next week we're going to be starting on review week, which means that you have 2 days of homework left. Lucky you guys. But this is a really fun topic. I'm just gonna write down the name and then I'll talk what it means. So this is integration by parts. Integration by parts. What does it mean? So this is, we've had the so-called, you have antiderivatives, right? So you had like the anti-chain rule. That was U substitution. Now we get the anti-product rule. So the anti-product rule is how you want to think about integration by parts. In other words, we find the integral f times g, I'll say f of x times g of x, actually that's probably safer. Integral of f of x times g of x dx. We find the indefinite integral of two functions multiplied together. And it's a bit fun to learn how to do this. The way we approached the inverse chain rule or the anti-chain rule was we looked at like what sort of a form the derivative was. It was f prime of g of x times g prime of x. We were looking for that in an integral. We don't quite do the same thing here. I'll write it like this. Consider the derivative d dx of, let's say, h of x times the integral of f of x dx. So we have a function on the outside that doesn't have an integral, and then we have f that does have an integral. We use the product rule. We can do the product rule. It's the derivative of the first times the second plus the second times the derivative of the first. Product rule says derivative of first, h prime of x times the second, plus first derivative of the second. Now what's the derivative of an integral? You guys are all yelling at the screen right now. It's just the function. This is exactly what our fundamental theorem of calculus says. The derivative of the integral is just the function itself. So all of a sudden, we have a d dx on the left-hand side, and it got rid of the integral on one of my two pieces here. So now let's integrate both sides. You guys can tell exactly why I'm so excited about this, because it's like real math that I would be the kind of person to care about, and you guys are just like, no, none of us care. So we integrate both sides. We get h of x times the integral of f of x dx equals the integral h prime of x times the integral of f of x. Now this is like a nested integral here, which looks weird, dx, plus the integral h of x times f of x dx. And you guys are like, what is going on? Okay, so this is the point. This is what we were looking for originally. So that's the piece we were looking for originally. I had a G earlier. Maybe I'll switch that to an H. If you look up top here, integral of one function times another function. That's how you want to think about that. And then you look here. It's an integral of one function times another function. So what should I do? I'm going to isolate that. So isolate it. Really solve for it. Isolate it, however you want to think about that. What is it? It's saying that the integral of f of x times h of x dx is equal to, what is this first piece here? The first piece is h of x times the integral of f of x dx minus, so all I've done basically is I've subtracted this on both sides and then rewritten everything else. I'll write that maybe in here. So subtract this off. Subtract from both sides. So equals h of x times the integral of f of x minus, now I have the integral of h prime of x integral f of x. There's really dx there. Don't want to get too crazy about that. There's a dx there. Dx. So you get this weird, this is your integration by parts, but we have a better version. So that's integration by parts in its truest setting, but there's a better way of writing this. I'll do double lines so that you guys can actually find this. The actual way we write it is the integral of u times dv equals u times v minus the integral of v du. I don't know if that's a better way, but that's the way I was taught. The new way, the way at the bottom, is the way I was taught. It's the way the book teaches. I'm going to stick with it for now. Maybe sometime when you see me in the future, when you come back for your saying hi to your favorite math professor days, then you'll tell. I might be switching back to that top version. I like the top version better. It's the one that I use in my head. But the bottom version is the one we use. Basically, I'll explain why we use it. Basically, we say that if I were comparing to the above case, U is playing the role of H and F is playing the role of dV. So U equals H of X and F of X, dV equals F of X. In the above. So that's the way we can think about it. And I'll show you how to use this. So this is actually the way we write it. Because if U equals H of X, then du equals H prime of X dx, and if dv equals f of x, then v equals the integral of f of x dx. And so then when I compare it to the above, everything actually lines up. It's actually the exact same expression. You see h of x dx, so you see f of x dx is dv, right? So this should be dx. And then du is h prime, which we see right here, h prime dx, there's du. This is really v, and that is really dv. So, I mean, whatever way you want to think about it, you think about it your way. I'll show you now how to actually use this. So how do we actually use it? Well, just like with u substitution, you need to choose u and dv wisely. Then everything works out. So let's do a quick example, the easy example. This is like the stereotypical one that everyone's going to give you. The integral of x e to the x dx. So you'll notice that if it were x e to the x squared dx, we could use u substitution, but in its current form of just x e to the x, we can't. And so this is indeed a product of functions that u substitution fails with. That's kind of what you want to think about first. If u substitution fails, then it's probably integration by parts problem. I'll say that. If u sub fails, it's likely integration by parts. And this might not be explicitly clear why we choose which one we choose, but I'll explain why later. We're going to let, for now, we'll let u equal x and dv equal e to the x dx. Now the fact is these d's, right, the reason I'm writing dv, these are still differentials, right? Still differentials. Think about it like a derivative. So this is very similar to u substitution, where we wanted to find u and du. It's just this case that the du part can be a different function altogether. That's why we kind of use it when u sub fails. The du part is a different function altogether. So u is x, and then dv is e to the x dx. And you want to think about that as the derivative of something. And so if dv is the derivative of something, we need to find, we need to find du and v, right? Our expression up top requires u and dv getting identified right away, and then we need to find, well, we already have u, we need to find v, because we have v twice, and we need to find du. So we'll use this to find du and v, and the du comes the exact same way it did with u substitution. So du, if u is x, du is just dx. V, all you do is integrate dv. So the integral of dv is the integral of e to the x dx, and you guys love this, it's just e to the x. So now we've identified u, du, and v. And so we can plug each of those in. So integral u dv equals u v minus integral v du. You're going to get that stuck in your head, I'm sure, even though we'll still have open notes for the next exam. Get that stuck in your head, uv minus v du, we just plug in the pieces. U is x, v is e to the x, minus integral, v is e to the x, du is dx, and so what do we come up with? X, e to the x minus e to the x. There is your integral. So this is like the most basic integration by parts problem you'll probably see, and then it only gets harder from there. But this is a good one. It kind of gets the priority going. So I'll put the steps down. So steps for an integration by parts problem. So step 1 is identify u and dv. Now, just like with u substitution, we have a priorities list for this. Priorities. So the priorities here is that u is a polynomial if it exists. I'll put the priorities in order again then, the way we like to do it. So I'll just have two sets of numbers, it's fine. Priorities, 1, polynomial for u. So first is a polynomial, second is going to be, first is going to be, man, this is tough because some problems are one way and other problems are another way. I'm going to write it like this. So u is first going to be the natural log. Second, it's going to be a polynomial. And for those of you who forget what that means, this means like x squared, x plus 1, x cubed minus 2x, etc. And then the third case is that it would be e to the x, but this just doesn't happen. Like ever. So just don't forget about that. Never mind. You have two choices on you. Now dv is going to, in the first case, it's probably going to be e to the x or other exponential. And then in the second case, it'll be, I guess it'll be dx. Well, no, it'll just be whatever else is there. Yeah, I mean, honestly, that's what it is. You guys love seeing me think, right? dv is whatever else is sitting around. So there you go. So that's step 1 is identify u and dv. Step 2 is you need to find du and v by, this is pretty easy, du equals u prime dx and v equals the integral dv. Easy enough. Step 3, you get your answer. It's uv minus integral v du. Step 4 is you actually compute that last integral. So there you go. There are your steps. And that's a good way of doing these problems. So let's do another example. It's the integral of x natural log of x dx. This is where I say go up to our priorities. Well, we really just follow our steps. Identify u and dv, but our priorities for u, first of all, is ln of x, and we have it. Is ln of x there? Yes, it is. So we're going to let u be ln of x, and then in our priorities, dv is whatever else is sitting around. What else is sitting around other than ln of x? X dx. Step 2, find du and v by du equals u prime dx. Derivative of natural log is 1 over x dx. V equals the integral of v, dv, right? Integral dv, but that's integral of x dx, which is x squared over 2. So this is really step 1 above. This is step 2 above. Step 3 above is uv minus v du. So this thing equals, write an equal sign here. Equals uv minus v du. Equals uv minus integral v du. What is that here? U, natural log of x, v, x squared over 2, minus integral of v is integral of x squared over 2, du is 1 over x dx. And then once again, simplify this. Don't ever try to take integrals before you simplify them. You're just going to end up in trouble. Step 4 is actually compute that integral. So you have x squared over 2 natural log of x minus this integral. If we simplify it, what happens? You get a x divided by 2 dx. So really that's x squared over 2 natural log of x minus x squared over 4, because there are really 2 2's in the denominator. Don't forget your plus c. I guess I should have added that before, shouldn't I have? I'll do that now. Plus c. It's not a huge deal, just like we should have it in there. Okay, so that's how you do this one. So follow the priorities, follow the steps, and then everything's going to work out for you. The priorities every so often don't work, just like we saw the last time. There's always a little bit to worry about. I'm going to look over your homework, make sure you can handle everything on there. Okay. Yeah. Right. So let's do one of your homework problems. So you might have to do this. I'll just say this here. You might need to repeat integration by parts. What I mean by that is if I have an integral of x to the n times a function dx, this is going to be integration by parts n times. Okay, so you just have to repeat this, and I'm not going to tell you how to do the one on your homework because I think you'll be able to pull it off, but you have to you'll end up having to repeat this. So that's why I wanted to throw that in there for your homework. And then another thing is we'll look at this one. One more example so that you guys don't feel super unprepared. 3 square root of x natural log square root of x dx. How do you do this one? Well, we want to follow the priorities, right? So step 1 is identify u and dv. So go up here, identify u and dv. Well, the priorities on u, step 1, priority 1, is a natural log. Really, this isn't the natural log of x, it should just be a natural log of something. And here we have the natural log of something. It's a natural log of the square root of x, so let's let that happen. And then dv is everything else. I'm going to pull the 3 out because we don't have to worry about that, so I'm not going to. We could include it, but I don't want to. So dv is going to be everything else, root x dx. So that means in step 2, if we need to find du, well, what is the derivative of the natural log of root x? That's going to be 1 divided by root x times the derivative of root x, which is 1/2. 1 divided by root x. What do you know? It's 1/2 1 over x. And you guys are screaming at me, why in the world is that? That looks like the derivative of the natural log. It is the derivative of the natural log because of the powers that natural logs do. So, of course. Anyway, we want to find v as well. V is the integral dv, which in this case is integral root x dx, also known as integral x to the 1/2 dx. Well, what is the integral of x to the 1/2 dx? It is x to the 3/2 over 3/2, also known as 2/3 x to the 3/2. Okay, so then step 3, you know what? I don't think I'm going to finish this one for you guys. I believe you guys can finish this one. I'm 100% certain you guys can finish this one. Step 3 and 4. You guys finish it. So I just want to get you guys started on those so that you didn't freak out and I didn't get a bunch of questions. Anyway, this is a really cool, nifty idea. Nifty, like the 50s, nifty 50s. All right. See you guys tomorrow for our last day of actual lecture. Have a good one. Bye.